Hello everyone, welcome to another tutorial in my channel about writing a polynomial given the roots. So, if you are given roots and you would like to write a polynomial regarding the number of the roots, in my previous tutorials I have introduced for you the fundamental theorem of algebra. The number of the roots must be equal to the number of the highest degree of this polynomial, and at least one of these roots must be in the set complex, and we took Descartes' rule. Now, if we are given roots, how can we write them? Also, I would like to revise a new concept for you, which is related to other lessons that you took before. It is about complex conjugate theorem. So it is a new theorem for you, but you know the term complex conjugate. So let's review the vocabs with you. So whenever you are having two complex numbers and they are having opposite signs of the imaginary part. So let's remind each other by what is the complex number. It is a plus bi. This is the real part and this is the imaginary part. So whenever you are having complex conjugate, that means one of the imaginary part will be positive, the other one will be negative. And in this case, I can call them complex conjugates. And now what is the complex conjugate theorem? It is that whenever you are having or you are given roots of a polynomial and he's only giving you a plus bi, you must understand by yourself that there is another complex conjugate. And for this reason, I was telling you in my previous videos, please refer to them if you did not watch them. I told you that you will be having even number of complex roots or imaginary roots. So if you would like to write a polynomial, it will be in this form: f of x, a, which will be 1 in your book, because all the examples given in your book as a is equal 1, x minus x1, and this x1 is the first root, x minus x2, the second root, multiplied by x minus x3, which is the third root, until you are having the same degree. So let's see this question. So if I was telling you write a polynomial function of the least degree with having the given zeros. So in the question, he only gave you 2 zeros. But we know the complex conjugate theorem that I don't only have these, I also have the complex conjugate of x2, which is x3, as 5 plus I. And since I have 3 roots, so I expect my degree to be equal to 3. So the highest degree at the end should be degree of 3. So let's write it together now, and let's pay attention to this. First of all, if I want to write f of x will be, as I told you, a will be 1 in your case. So x minus x1, x minus x2, and because I have only 3 roots, so I will be stopping here, x minus x3. So let's substitute together. f of x, x minus 1. So we will replace this later. X minus 5 minus I. Then x minus 5 plus I. Let's now simplify it further. So this is all about x plus 1. Then x minus 5 plus I. Keep the real part alone. x minus 5 minus I. And let's keep this in brackets, and now you will know why. Great. So until this step, all what I did is only simplifying. Now let's use the method of factorization and the method of having two binomials which are related to each other, and let's now grab it again and put it together. So let me remind you by one of the characteristics of factorization. Whenever you are having a square minus b square, think how can you factorize it? It is a minus b. It is difference between two squares. A plus b. Now I'm having these two and I want to get the polynomial or the binomial which gave me these two brackets. So it's like I'm doing my work on the reverse thing. So let me delete this one. It was only a reminder for you. So let me expect that this is A and this is B. This is A and this is B. So if you notice, you have A plus B, A minus B. So now let's take another color and show it for you. So I didn't do anything with the first part. I will leave it as it is. So again, we were saying that we will take the first one and we will be squaring it, which is A. So x minus 5 all squared. Then because it is difference between squares, then it will be minus I squared. I multiplied by I squared. Now let's simplify this further and let me remind you by the square of addition or the square of subtraction. So this is, you talked it before, whenever you are having like this square of subtraction, all what you need to do is square the first part, square the last part, and then minus 2 multiplied by the first and the last, 2ab. Then add it to each other. And then what you need to do is now use this method is to find this simplification and simplify. So x plus 1, so x plus 1, you will be having here factorization of this part. X squared minus 10x plus 25. And this is one of the characteristics that you should know, that it is already equal to what? Hurry up, answer with me. Pause and answer. So yes, so I squared, it's all about minus 1, and with this minus and minus, it will be plus 1. So now let's simplify it again. X plus 1, x squared minus 10x plus 26. So all of these is equal to f of x. Let us now make the distributive, and we will be simplifying it further. So we will take x, it will be x cubed, then we'll be taking this one with this one, minus 10 x squared, then it will be plus 26x. Now plus x squared minus 10x plus 26. So let's now simplify it together. So f of x will be x cubed. And now let's simplify the like terms. So it will be minus 9x squared. Then let's take the other like terms. So 26 minus 10, calculate it please together. Then it will be plus 16. Now what you will do here, are you having other like terms here? Check please, are you having other like terms? So no. So you will leave the variable here and the other number without having any like terms. Always do not write the final answer until you check all the like terms. And this is the whole idea of how can you write a polynomial with given roots. Now we are having another example. You are given 2 only. Again, whenever you are given only 2, so that means it is already 3. So minus 1, x2 is 1 plus 2i, and you should know that you have another complex conjugate, 1 minus 2i. So if I would like to write f of x again, so it will be x minus, so now let's solve it directly. X minus minus 1, so it will be x plus 1. Then now I will be trying to solve it with you directly. So x minus this expression, so x minus 1 minus 2i. Then x minus this expression, so it will be x minus 1 plus 2i. If you did not get this step, please refer to the previous slide in the video and you will find the step by step. Now let's simplify together. I will be taking all of this together and all of this. Then directly in one step, I will be taking x minus 1 all squared minus 2i all squared. Let me now simplify. So f of x, x plus 1, then x squared minus 2x plus 1. Then this expression will be for u plus 4. Okay, and let's substitute further and simplify because you have here like terms. F of x, x plus 1, and then you are having here x squared minus 2x plus 5. Whatever you need to do is you need to distribute as we did before, and this one with this one, then take the like terms. The final answer will be x to the power of 3 minus x squared plus 3x plus 5. So this is the final answer after distributing. If you would like to review how did we do it, please refer to the previous question. So please pause and practice. I will give you a hint for 14. you are having already 4 numbers and all of them are real numbers. So what is the degree? What do you think? You are having 4 roots. So yes, excellent. It is degree of 4. Now let's look at 15. You are having 2 real and 1 complex. Where is the conjugate of it? So yes, it is degree of 4 because it has 4 roots. So that was my hints for you. I would like you to revise this video until you be able to practice. Please comment for me whether you did well or not. Thank you so much, and that's the end of the video. Wait for other tutorials.